My name is Crosby Lyles, and this is News from the Can. So this is 2022 Oppenheimer lecture, The Quantum Origins of Gravity. This is Leonard Susskind, the venerable Leonard Susskind. Quick comment here. Comments are turned off on the video. You know, guys, I think it's just a better public relations to have well-policed, policed is probably a bad word, but well-moderated, let me say it that way, comments. And if it's a learning institution, you got plenty of, a large workforce that can handle that. That's that. Okay. So, as I said, my name is Crosby Lyles, and this is my story. I've kind of been looking for this for a long time. Between 20 and probably closer to 25 years ago, I thought of this myself. ER equals EPR, and that's Einstein-Rosen is equal to Einstein-Podolsky-Rosen, which means basically entanglement equals an Einstein-Rosen bridge. In other words, entangled particles are entangled with a wormhole. And I thought of this 25 years ago. Now, in all fairness, there might be hundreds or thousands of people that this has occurred to already. But they said, well, I don't know enough about particle physics. Particle physics is a very daunting thing. You see a lot of things about Schrodinger, wave mechanics, quantum mechanics, and it's a scary, you look at fine diagrams and you're like, that's a lot of shit to wade through to get to sort of a common sense, because what else could it possibly be? The micro or the subatomic. So this is where we're getting to. We're getting to the thing and there's an intuitive sense here that the subatomic is related to the cosmological. And so one might even jump to a notion that they're mirrors of each other, that they're kind of sort of like, in a way, they're like duals of each other. And what he's going to explain in this video, all these links will be in the description. I saw this and I'm like, damn, I was right. And I might not be alone. Wormholes were in the zeitgeist in the 90s. We're talking about in the 90s, so the popular culture, the zeitgeist, wormholes were all throughout that. The movie Contact was all about wormholes and stuff like that, and Stargate, and and this has been dimensions, extra dimensions. It's been in comic books and science fiction since before I was even born. Okay, so it's in the zeitgeist. So it makes sense that in my mind, at least hundreds, maybe thousands of other people came to this conclusion any time within the last 50 years. So there's another part of this conclusion that I want to get to here. So they discovered that through all these different disciplines, through quantum computing, the science of quantum computing, and dense matter studies and things like this, that they were able to prove, and apparently to hear Leonard Susskind say this, through very precise mathematics, they're able to prove that this is probably fucking true. Okay, pardon my English. But there's more. So entangled particles are connected by a wormhole. In order to get to the proof, that might take something, but I'm just going to say it because I might as well. I mean, I was right about this. It's an intuitive leap, and I had this other intuitive leap 25 years ago. Protons, it's going to sound crazy. I'm just going to kick it out there. Protons are quantum black holes. And so when an electron finds a proton, because the whole thing came about what is an orbital? It doesn't physically orbit around No, it flies down the hole. The electron comes into the space and it flies down the hole. And so a proton actually looks like a little skate park. This is just the way I see it. I'm just throwing it out there. It's part of my story, my life story. So a proton is like a skate park, right? And so it has all these little, like it has a snake run, and it has a bowl, and it has another thing. These are the dimensions. These are different dimensions in that subatomic space. The electron flies into the thing, and it can take any number of these paths. Heisenberg uncertainty principle holds, and so the electron flies in and it flies out. But there's a wrinkle here, because when an electron flies through space, it is not always visible. It goes through these periods where it actually is like a fire. An electron goes through space like a firefly. It's visible and it's not visible, and it's visible and it's not visible. And so you see the electric field. Electric field goes up and down, right? That's kind of like not to scale really, but the electric field goes up and down, and it really acts. That's what it looks like. And so quantum tunneling, electron can pass through materials depending on what the electric field is like in that region, right? So because the electron, it exists and it doesn't exist as it flies through space. So when it finds a proton that's like a black hole, there's a space here where it's like it pops in and out of existence. So it finds this, and because of the amount of acceleration that you have here, it's going to go faster than the speed. It can't go faster than the speed of light, and mass increases to infinity in that case. So anyway, this is where you have the Schrodinger waveforms that come out like this, and the pi and the sigma and all of this stuff, depending on how many electrons there are in the system. So the proton is basically a black hole, is the smallest quantum black hole. So black holes are composed of many quantum black holes. And a neutron is a proton with an electron in a very low energy orbital. And so the connection is that the electron flies back and forth between the protons. So is that true? Is that provable or disprovable? I'm sure that anybody that's got even a minimal physics degree could probably prove or disprove that instantly. And there's something that kind of disproves this, and I don't remember what it is. So now this is old. This is just my thoughts from 25 years ago. This is what I thought 25 years ago. I was thinking about it. I was thinking about what if. Okay. What if? So gravity, I thought back then, was that gravity is just the attraction of the black hole, but it's mitigated because the force of electrostatics is enormous compared to the force of gravity. Force of gravity is very small, it's tiny, very very small. The force of electrostatics is enormous. It's so strong, in fact, that this is where the magnetic field comes from. The magnetic field is the relativistic transformation of electric force between reference frames. And that magnetic force can be extraordinary. And this is from drift current that moves as fast as you can walk, meters per second. And a drift current can generate magnetic force that's very strong. Okay, so it's a strong force. But what it's mitigated by is the fact that the electron is in this orbital. So the point is that it would be a trick that someone might be able to use to create anti-gravity, possibly. Although it's not gravity, I would say, gravity is described by special relativity. That Einstein, that's it, curved space. Thank you very much. But that's what a proton is. In one sense, the quantum electromagnetic force carrier principle comes into play when protons are held together by an electron traveling between two protons, one of them being labeled as a neutron, which would be a proton with an electron in a very low orbital. And the thing is that nobody's ever seen a proton decay. It's postulated, and what I thought that was is really two electrons in a large nucleus colliding inside here somewhere, you know, where two electrons end up colliding inside the same black hole and producing something that looks like the collision of a positron and an electron. With the annihilation, you end up with a gamma ray, and that's supposedly a positron emission. And there may be other things that prove that positron emission is real. And, you know, hey, look, this is the way I saw it 25 years ago. This is where my mind was at. But I'm like, you know, obviously there's other stuff to learn. But this is an intuitive landscape that I was trying to work. And a lot of physics there's a certain amount of physics that's counterintuitive. But this is what my mind said. And my mind said, you know what? That means that there's a waveform, that there's a square waveform. It's a pulse. So there's a pulse waveform that this produces. When an electron is in an orbital, it's not an analog thing. It's a digital thing. It goes bam, 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 like that. And it has harmonic frequencies. So that there's a mother frequency or a common frequency for all matter, or for large quantities of matter. And if you can figure out what that is, then you can pulse that frequency in a pan capacitor type of array or something like that. And you can produce a pulse that might be able to produce something that looks like a gravitational field, or that looks like an anti-gravity field, because it repels or attracts matter because of this phenomenon. But gravity per se, like having an anti-gravity thing, something that works on curved space, that's like a different, you know, then you're talking about the quantum field theories and things like that. But all comes down to matter pulses. Matter, you know, matter has a spring constant in it, or not matter, but space. So this is apparently where we're at. You know, the quantum expanse, you know, the quantum realm that we're in exists of expanding and collapsing springs. Spring constant. There's a spring constant there. There's a brain, if you will. There's a brain and a bulk. So one of the things that Dr. Susskind here is talking about is the idea of a hologram. And it's not in this video, it's in a different video. Links will be in the description. I think it might be this one here. There it is. That's what I'm looking for. He starts describing what's very important to this concept about black holes and entanglement and all this kind of stuff. He starts talking about the hologram theory. And he will say that everything that's in the bulk is described by information that's encoded on the surface. But that inside this bulk, no information, everything bounces off of the boundary, right? And I'm listening to him describe this, and I'm saying, that sounds like a resonant cavity. And you hear people talking about anti-gravity devices that are made that use resonant cavities. A lot of resonant cavities are used to accelerate particles at CERN. That's how you get your high-frequency electromagnetic waves that push those particles around the thing. They use a resonant cavity. Resonant cavities have been used a lot. Crystals are resonant cavities. And he talks about crystals that contain a hologram, that you can make a hologram inside of a crystal. They make them all day long and twice on Sunday. So crystals are resonance. Matter of fact, different tissues. I know this because of photobiomodulation, something that my wife does. And a guy named Norgay went around with tuning forks and measured the resonant frequencies of different tissues, livers and lungs and hearts and muscles and this and that. And so what they do is they pulse the light. Pulse light, from personal experience, to me, works way better than just, near infrared. It's like 890 nanometers, something like that. 980 something nanometers. I can't remember right off the top of my head. That has the best penetration up to 8 centimeters into the body. It has to do with the mitochondria. The mitochondria absorbs a photon, this and that. The frequency of the light is in hundreds of nanometers, 800, 900 nanometers, somewhere in there, optimally. But they pulse that in frequencies of sound. So Norgay frequencies, there are several, but I mean, they use a bunch of different, it's like they have whole, monk, type of stuff going on there. You can put a light wand up to my ear and you can hear it going through the root and the fifth, and it'll go up an octave, and then it'll go up another fifth or a third or something like that, and then go up another octave. And it does that, and this is more effective. It's more effective at pain relief and all this kind of stuff. So, because tissue is, a crystal is organized matter. That's what a crystal is. So it kind of blew my mind when I heard that the first time, and there was somebody who was talking about, fluid dynamics and things like that, and water is a crystal. And it organizes itself, laminar flow and different temperatures, and, because you're talking about energy levels, right? There's a thermocline in water and stuff like that. So I'm kind of getting off topic here, but basically matter in its different forms has a resonant frequency. Everything's has a resonant frequency, right? So protons have a resonant frequency, and apparently it's somewhere on here. And I don't want to get off base here, but he was talking about black holes. Black holes ring like a fucking bell. The moon rang like a bell. You know what I mean? Which is fascinating. But so, and it's, there's a connection here. I'm listening to him talk about the nature of a hologram, and I'm saying, that sounds like, I know he's talking about a hologram, but that sounds like a resonant cavity. So, can you use a resonant cavity to produce? Can you use a resonant cavity to produce something hologram-like? So anyway, that's basically where I'm at. I've been thinking about this for 25 years, but I'm like, I can't really talk about it because I have to slog through all the stuff. Particle physics, string theory, forget about it. All of the stuff that, Leonard Susskind, he's slogged through all of that material and is intimate with the mathematics, and others, that's why I'm a gnat on a dog's ass. I'm here to tell you right now, and that's okay. God uses cracked pots and broken vessels. So whether I was just, this is something that I came up with because the zeitgeist back in the 90s was all about wormholes and stuff like that. Stargate was popular on television somewhere. You know what I mean? I never really watched it back then. I didn't really care for it. It looked silly to me. I didn't get into it. But I did binge watch it later on, and they have some science in there. Like when they first went through the wormholes, they would come out of the other side and they would be brushing snow off, frost off, because it's supposedly inside of, I think this is where they got that from, supposedly inside a black hole or a wormhole, entropy is infinite. And supposedly it's infinite because, because of uncertainty, because uncertainty becomes infinite, or I don't know. There's got to be some stuff in there with, they was talking about surface area, area in general, related to entropy, and entropy is a deep subject. And why I say that, because the way I've heard entropy explained is you take a deck of cards that's in order by suit and by number, in the box, as its lowest entropy state. You take it out of the box and spread it out on the table, the entropy's higher. Shuffle it, and it's a little bit higher. So that goes all the way to the point where you just take the deck of cards and throw it up in the air, and it goes everywhere. So, and what that tells you is something about the order of a crystal, the order of matter, right? So if you take sodium chloride in a block, and there's one molecule or one atom of boron in there, that will mess up the lattice structure because you don't know where it is because of Heisenberg's uncertainty principle, and then it can blow your entropy way up. And, like entropy is like an intrinsic. I hope I'm right about that. I think it's intrinsic because, entropy, it has a fixed value. You can look it up for substances at a particular temperature, and I believe it's an intrinsic. It's an intrinsic value. So, don't slap me down too hard. I believe that's true. So, anyway, there it is. So my story is that, and I'll be brief, I just wanted to get that out there. So, okay, so entangled particles are connected by a wormhole. Protons are little black holes. And furthermore, they are the quantum element of potential energy. The lowest quantum element of potential energy is the proton. The smallest quantum element of kinetic energy is the electron. And if you look at the way they behave, and how they, it's like if you put electrons in a circular accelerator, then it'll give off electromagnetic radiation and cause it to slow down and create all kinds of problems in the neighborhood, where you've got running your experiment. Whereas a proton doesn't do that. So it's a different, it's a different thing. The proton is, and so this is just crazy thoughts. You know what I'm saying? Just being crazy here for a minute. Proton's the lowest or the smallest unit of potential energy. Electron is the smallest unit of kinetic energy, which is a crazy kind of, you think of potential energy as you can take whatever you want, a rock, a baseball, your computer monitor that you just threw across the room as kinetic energy, 1/2 mv squared, plus or minus whatever. So what does that necessarily mean? It means that it's a node in space-time. The consequences of all that stuff, I'm sure that when somebody, one of these very intelligent people, any number of people who are even fractionally more learned than me, certainly, would be able to whittle all this down, and experimentally it's probably, probably toast already. But that's okay. So my story is that and it's for entertainment value, whatever. You know, I went to school briefly in the early 80s, and then got involved in business. I went into business and stuff like that, and so I'm a musician. I started writing songs. I wrote some songs, and I went and as a songwriter, I started working out of Miami, and you know, I'm not really working, but putting my songs out. And I went to a venue one night, and I opened for the Mavericks, interestingly enough, and I had a very good night. And the people, I basically went on, it was an open mic night, but the featured artists were the Mavericks. And they were like on Johnny Carson and stuff at that time. So I ended up, I played for this audience, and this was kind of a country kind of audience, whatever. They liked my material. They didn't want, you know, they gave me an ovation. They wanted to hear another song, and at the protest of the guy running the place, Doc. Anyway, so I played this set, and it was great, and I felt all this validation and stuff. I'm like, wow, people like my stuff, and I felt totally validated and stuff, and all this. And I got off stage, and I went around to the back, and was putting my guitar away, and I had like this dark night of the soul. Became morbidly depressed. I'm like, well, what am I going to do now? Damn, what am I going to do now? And so somewhere along there, and the intervening, this period of time, not too long after that, I said, man, I'm gonna have to find something more durable. You know, I'm gonna have to find something. I'm gonna figure something out that's gonna take a long time to figure out, a lifetime, something that's just impossible. And I kind of like, yeah, anti-gravity sounds like a thing. I'm gonna figure out anti-gravity. That'll be like a lifetime thing. And I ended up going back to school. I started looking at stuff and studying stuff, and, you know, and chemistry and physics and all this kind of stuff in a short amount of time there. And I went back decided to go back to school. I ended up here at Santa Fe Community College. I ended up going to University of Florida for a while. And in that period of time, in the late 90s, is when I started really thinking about this stuff. And I even brought this up to an instructor, a physics instructor over at, I can't remember the guy's name, over at Santa Fe Community College. I said, yeah, I think our protons are like little black holes. And the guy really didn't didn't have an opportunity, because office hours is other people to see. There was something that he brought up, and I don't even remember what it was, that basically shot it down immediately, and I don't remember exactly what that was. And there's probably some matter of basically what it means is that it is a black hole, is that there's something about that order of magnitude of size, if you will, or probably has something to do with axial acceleration or something, a limit of axial acceleration, something along those lines that causes that size to be a sweet spot for that thing, black hole, proton, whatever. Anyway, so I mentioned it to an instructor, and he kind of sort of shot it down, and I thought, well, in pretty much short order, and I don't remember exactly what he said, and I'm sure it's somebody can shoot it down pretty quickly. Being shot down is not bad. It's a learning experience. So I got graduated with honors over there, and I got into University of Florida, and it's a different environment. I kind of like, I don't know. It's kind of weird. There's a thing that happens with expectations. I'm like, the way that they run the classes and stuff, and it was awkward. It was awkward, and I didn't do that well. I didn't do as well as I probably could have. I wish I could go back and redo that, but just take less classes and sort of, once you know how the situation runs, it's easier to do. But it was, I don't know, it was weird. It was a weird experience in a sense, but the instructors are very, were awesome. I gotta say, they were awesome. So this is let me just get to this. So I'm going to school, And I don't know if I have it around here somewhere. I got it around here somewhere. It's probably over there in that pile of books over there. Electromagnetic fields and waves. So I take them electromagnetic fields and waves. It's one of the, it's electrical engineering. That's part of your coursework. And I'm studying it. And now this is a modern, more modern, if you will, electromagnetic fields and waves book. And I'm doing the work, and I'm like, okay, I know how to calculate a magnetic field. You can figure out what the wavefront looks like and all that stuff, and I can calculate a magnetic field. But what is it? So I went around all my instructors one day. I said, I'm going to find out. I'm going to nail somebody down on this. It's like a mystery. The internet was fairly new back then. It wasn't, it was, we're talking about maybe 2001, 2002, somewhere in there. I'm not a traditional student. I went back later in life. 33 when I started back to school. My dad was an electrical engineer. He was a very good electrical engineer, as a matter of fact. So I went around to the chairman of the department. Anyway, I went around to a bunch of them. Dr. Rockoff, I think he's still over there. And I asked him, I said, I can calculate a magnetic field, but what is it? And they kind of brushed me off. They didn't really give me a straight answer. And I'm like, and I thought that was puzzling. So I guess I would have had to get on the internet at that point and kind of look it up. But it's like, when you ask the internet, what's a magnetic field? Even up until like not really that long ago, you would you wouldn't get a straight answer. There's a simple answer. A magnetic field is a relativistic transformation of electric force between reference frames. That's it. It's a relativistic transformation of electric force between reference frames, basically. So you can take Maxwell's equations for electrostatic force, and you can transform them all into the Maxwell's equations for magnetic blah. Using special relativity, using the Lorentz transformation, right? 1 over the square root of, 1 minus blah over c squared, something like that. Gamma. So, I don't have to look at it. I don't remember right off the top of my head. Anyway, so there it is. But they didn't tell me that, and I didn't know that, and that's because it wasn't in the book. So some shit went down in my life, and it's really unfortunate, and I'm basically, it's very tragic, and lost a loved one and stuff, and went to prison. And I went to prison for 8.5 years. So the first place that I stopped after the county jail, after 15 months in the county jail and going through intake and all that stuff, I went to ACI. And I ended up at the work camp at ACI, where they have a library. So one day I'm like, I went in the library to look around and see what they had. They got a law library in there, which most institutions have to have. Thank God, And but anyway, I went in there, and there was a book on it was Electromagnetic Fields and Waves by Lorentz and Corson. I thought, oh, that's cool, and I started reading it. And of course, from the incident that happened, I was like wiped out. Like really mentally, physically, and spiritually wiped out for about 5 years. Longer than that, really. Long time. It takes a long time to recover from something like that. And it's not a complaint. I can't complain about it because somebody lost their life. It's kind of terrible. But what are you going to do? You ask yourself, well, what am I going to do? It's not really going to be helpful if I just die. So, got to do something. And basically, I kept going just because I figured that was probably the right thing to do. So I got this book. I found this book, and I started reading it. Chapter 3 or 4 in this book that was written in, I think it might have been published in 1970 or 69, 70, 71, somewhere in there. Chapter 3 or 4 starts on special relativity. And I'm like, that's interesting. And it had 2 or 3 chapters on special relativity. So where they start in electromagnetic fields and waves is they start with analytic geometry, vector calculus, and a certain amount of linear algebra to remind you about, the aspects of linear algebra, because you got to kind of have that. Basically, a reminder of how to do a lot of this stuff, and that's the first 2 or 3 chapters, right? And a little bit about some other, basic stuff, and then it goes right into special relativity. I'm like, wow, that's really fascinating. Special relativity. Well, that's special relativity. The reason that Einstein wrote special relativity is not that he gave a fuck about a child throwing a ball on a, tossing a ball up and down on a train. There's nothing about that. It's all about the consequences of relativity on charged particles. And God, I don't remember the title. The original title of the paper that he wrote was about electromagnetism, and that you can actually derive the Maxwell's equations for magnetism from the Maxwell's equations from electric force using special relativity. But that's not, I don't necessarily think that's what was in the paper per se. I'd have to read it. I haven't read it. Because I'm not one of those guys that's going to read everything I can get my hands on, because what happens is that there are things that will distract me. There's a lot of clutter in there. I'm trying to get right to the, to find the thing that I'm looking for, that I intuitively know that's got to be there. Anyway, so there it is. I had to go to fucking prison to find out, oh, well, the magnetic field is the relativistic transformation of electric force between reference frames. That's what it is. And that's enormously, how the hell can you teach anybody electromagnetic fields and waves without that little tidbit? How on earth? And it's because now Dr. Bullock, who's now deceased, rest in peace, he was a Stanford guy, and apparently so was Hal Puthoff, Stanford guy. Dr. Susskind, I think he got his PhD Berkeley, somewhere in there, UC Berkeley, something like that, string theory. But anyway, he lamented when I talked to him. I asked him, and he was awesome. Dr. Bullock, down to earth. That's like Stanford. It's like must be part of the culture there. Very down to earth. And he lamented. He said, well, colleges now, colleges used to be like institutions of higher learning, and now basically it's just a vocational school. Like, well, okay, that's fascinating, but what the fuck is a magnetic field? And nobody would tell me, and they didn't give me a straight answer, and well, I don't know. I don't really know what to tell you. I didn't want to waste any more time with me. Hey, look, I understand. Motherfuckers in their 30s are scary. You don't really know what they're about or what they're on. It is weird. So I don't blame them. It's okay. But, I had to go to prison to find a book that would tell me, that would answer the question, that answered that question. And you know what? I might not have found it out otherwise. Sooner or later, I probably would have seen it somewhere on the internet. Had I not gone to prison, I probably would have, maybe graduated, maybe not, and got some job somewhere, and might never have found out. Might have just gone through blindly, you know, found out way later in life. But wow, you know, saw that book and bam. So there it is. And because, you know, they like to keep things mysterious. School is not really necessarily there to teach higher. In a lot of colleges, it's not really about teaching higher learning. It's about kicking your ass, getting you to be more efficient, you know, and separating the wheat from the chaff, you know. So, but hey, it is what it is. I don't know if it can really be any different, you know. Smart people are coming out of the woodwork any way you look at it. And typically, if you're really going to make it in the world, you basically have to pop out of your mama's pussy a fucking super genius, or, you know, just go out and grab yourself a shovel and start digging shit for a living, you know, or whatever. You're a slave, you know. Better pop out of your mama's pussy with a fucking guitar in your hand and play 8 hours a day for the rest of your life. You want to be a musician, you know what I mean, with an incarnate fucking knowledge of, you know, music theory and everything else. You know, you better just be a wonderkind right from the start, or go fuck yourself, pretty much. But anyway, that's it. Leonard Susskind is a fabulous human being. Thank God for him. And that's the ideas. And I'm putting it out there because, you know, basically I'm inspired to basically speak up about this because, you know, at long last I found out, I'm like, oh shit, I was right. 25 some odd years ago, I said, yeah, that's right. ER equals EPR. Yep. Nailed it. And it's like, you can look at me and and it doesn't really mean anything other than to say, you know, to spit this other shit out, you know, about the proton, about what I think about the proton. Now it's up to proving it, and maybe some wonderkind out there can prove it. I don't know if I can. I mean, I got, you know, COVID. I got headaches now. I don't read as well as I would like to. I have to basically get a desk and stand up. You know, and that's like a COVID thing. I don't know if that's from the booster or if that's from, you know, whatever. They have like a little thrombosis warning on there and shit. It's like, so anyway, this is where we're at, and this is where I'm at, and that's kind of my backstory. It's tragic but true, and you know, it may just be that this drawing looks like a resonant cavity, but that's his description of what this is. Reminded me of a resonant cavity. You know, maybe a resonant cavity that has artifacts on, you know, on its surface, which is what that looks like. And as it resonates, then the artifacts on the surface impart information into the center. But I think that, you know, really getting a parse into the details on that. But anyway, that's it. My name is Crosby Lyles. This is my part of my story, and I'm putting it out there so that it's a matter of record. Here it is. You know, kind of like my theory, or it's not a theory, it's a hypothesis called the methane off switch hypothesis that basically shuts down global warming. But that's another thing. You can look it up. It's on my channel. But I'm just basically checking in with this thing. Protons are tiny black holes. Okay. Entanglement is a wormhole, and protons are tiny black holes with the little structures inside there, with a little extra dimensional, you know, 8 dimensions of possibility within them, right? Then the electron flies into the thing, and Heisenberg's its way around in there and pops out, and Heisenberg's its way into what we know are the Schrodinger equations, which I'd like to thank Science Asylum did a great video about that. The Schrodinger's wave equation is actually a heat equation. My next question is, okay, well, what is the second derivative of that right-hand side? What does that, you know, It's the rate of change of a rate of change. So what does that look like? Where it would actually be a wave equation instead of a heat equation. And that's all I got. I'm an ad on a dog's ass. Thanks, guys. Thanks for listening. And, thanks to Leonard, Susskind, and all the people, out there that are doing great physics material on YouTube. I'll put several links in the description from a lot of these people. Science Asylum, I don't have them up here, but the link will be in the description. It's awesome stuff. Right here, Arvin Ash. So this guy here has got some interesting... I think his material is pretty good. And, of course, look at all these people. Sabine Hossenfelder, excuse me. But these Arvin Ash is, of course, pretty good. And PBS, Space-Time, all those guys, fascinating. That's it. Anyway, that's it. My name is R. Crosby Lyles. Links are in the description. Peace.